Hello everyone. Today in this video we'll be discussing the third part of AI and ML module 1, and in this part we just have the topic which is heuristic techniques. Okay, so in that there are few techniques and the theory concepts which we'll be discussing, and seeing how you should write the answers in the exam and what are the key points, what are the important diagrams, and some algorithms are there. Okay, so we'll be discussing that. It's super important from exam point of view. You can get the questions from 8 to 12 marks from that. Okay, so before starting, if you like this video, hit the like button and don't forget to subscribe to my channel. Your support helps me make more videos like this. Okay, so make sure you hit the like button and subscribe to my channel. So let's get started. The first question is, so the notes can be found in the description box, and the other videos playlist link is also given in the description box. You can go through it, and wherever I have marked star, that is super important. Okay, so let's get started. Firstly, what is heuristic search technique? For that, you need to know what is heuristic, right? Because the part of the module is concerned with heuristic techniques. So unless you know what is heuristic, we cannot proceed further. So heuristic basically means hint. Just keep this in mind. Heuristic means hint. Okay, what do I mean by hint? Hint means any suggestion or any thing given to you by using which you can reach to your goal more easily, right? If there is a goal and you want to reach to it more easily, what you can use is hints. Okay, so heuristic means hints. If you have an algorithm, okay, so for example there are 10 things here. Okay, suppose that in this box there are 10 things present. Okay, and you have to pick one of those things. You can see all those things and there are of different colors. Okay, and you have to pick one of those things. If that thing which you picked is the right one, then you will be getting a reward. Okay, now if you don't have any hint, you will be just picking something randomly. But if you get any hint, like whatever you are going to pick, that is in a circle shape and orange color. Okay, circle shape and what, orange color. So obviously you will see which is in circle shape, and then you will see which is orange color. Obviously you will be picking from that only. So what is that information? This is the information known as hint. In the heuristic technique also we'll be doing the same thing. Whenever there is a problem given and we have to find out the solution to it, we'll be performing the algorithm as usual, but also we'll be using some hints. Hints in the sense we'll be using the domain knowledge. Okay, means which answers will be most probable that there are the correct answers, which answers are more probable that they are the correct answers. Those answers only will be picking. That is known as heuristic technique. So we need knowledge of the domain for heuristic techniques. That's the compulsory thing. Okay, one of the things which we need for heuristic techniques is the domain knowledge. There are many problems which can be solved using AI, but complex problems are relatively new and could only be solved using heuristic methods. Why? Because in complex method it takes a lot of time, because there are many possibilities which could be the answer. If you use heuristic techniques, from those many techniques it will be boiled down to just few techniques which are actually relevant. Others will be eliminated. We need not compute the resources and the time behind them. Okay, so those are what heuristic techniques. So repeat after me, what is heuristic techniques? We'll be using the domain knowledge. Okay, we'll be using the domain knowledge to find out an answer to the given problem using an algorithm. If you write that much, it will be sufficient for the definition. Then comes, there are two types of it. Okay, so how many types are there in heuristic? Two types are there. In fact, non-heuristic and heuristic, those are the only two types. Non-heuristic means uninformed. Uninformed means the hint was not given. Hint was not given. Search algorithms, also known as uninformed search algorithms, search all possible answers. You see what they do? They search all possible answers and check whether they are right or not. So in that it takes a lot of time, because you are checking every single answer, right? And on the other hand, we have informed search algorithms, also known as heuristic methods. They search only the specific results that move closer to the actual answer. So the hints take us closer to the actual answer, right? So we'll be using the heuristic methods for complex methods. So this is what you have to mention as a brief technique. Like if they ask for less marks, you have to write this one, else you will get to know what you need to write in the upcoming topics. Okay, so this is what the general information about heuristic techniques. So breadth first search and depth first search we already know from third semester. What is breadth first search? By the name itself you can understand. Breadth first, what do you mean by breadth first? If you have a tree like this, breadth first means it will explore all the neighboring nodes first. First this node, then this node, then this node. Then if it has child nodes here, then it will be exploring the child nodes as well. But in depth first search, what will happen? It will go like this, then come back, go like this, again come back, go like this, come back, go like this, come back, go like this. That is depth first search. It will not explore all the neighboring nodes, but it will go to the depth. It will explore this one, then come back again, go to the depth and explore, and again come back, unless we get the correct answer. Okay. So that's the difference between breadth first search and depth first search. Breadth first search is a search strategy in which the highest layer of the decision tree, highest layer is which one? This is the highest layer. Next highest layer is this one, this one. Next highest layer is which one? This one, right? So the highest layer is searched completely before proceeding to the next layer. We cannot search this node unless all the nodes in the above layer are already searched. Fine, this is the main concept you need to keep in mind. Now let's move on to the algorithm. In the algorithm, what we have is we will be creating a list and set it as starting state. List is nothing but a big box. You imagine list as a big box, and we'll be setting a starting state. So S I will be storing here. So let's make a tree here. S R T U V W. Fine. Loop until the goal state is found. Suppose that my goal state is W, and remove the first element from the list and call it E. If the list is empty, quit. For every path of each node, match the state E comma do. Okay, so see here, do is for the further steps what is to be performed. But I'll explain you in brief. You'll get to know what I am trying to say. We have stored S here. Remove S and store the neighboring nodes. What are the neighboring nodes of S? R and T. So I'll store R and T in the order. Then after that I have explored S, I'll be just removing it. Then I will be seeing which is the next one, R. So what I'll do, I'll explore R and I'll store the childs of R, which is U. Then after that R is over, I'll be going to T. I'll be exploring this one. Then I'll be storing the childs of T, which is V and W. V and W are stored. Then T is also done. Then I'll go to U. Then U has no child, done. V and W also has no child. When I reach to W, we will reach the final answer. What you observed, I moved in this way, right? I moved in this way. That is what breadth first search. For that, we'll be using this one. This is known as Q, first in, first out. First in, first out. S came first, first out. R came second, second out. T came third, third out, and so on until we reach the final state. If we end the states also and we did not reach the goal, obviously there is no goal in the tree itself. That's a useless tree, right? Without any goal, they just wasted our time, right? It's a useless tree. So that's what we'll be doing here. We'll be looping until it is empty. If before getting empty, if you find the answer, just quit. Fine. If the list is empty, quit. Or if you find the goal state, quit and return this state. Okay, that's same thing given here. You just have to go through it once. Moving on, we have the depth first search. In depth first search, we'll be searching till the end and the current path and possible backtracking before to the last choice point. So here what we'll be using is stack. Okay, why we'll be using stack? So let's take the same tree here. S R T U V W. Fine. In depth first search, first we'll be storing S here. Why we are using stack, I'll be letting you know. Then we'll be using storing R. We'll be choosing one and going in depth U. After U nothing is there, I'll cut off this one and I'll go to R. Nothing is there, I'll cut off, I'll go to S again. When I go to S, I have T also. First I'll store T, then I'll store V. I can go like this, right? V. Then after V nothing is there, after T nothing is there, again S is there. Again S, T, then W. Sorry, I'll not cut T, T will be like this only. When I get to T, I have another choice, W. So what I'll do, after this I'll store W. If I get the final answer, I'll just return it final answer. If W is also not the goal, I'll cut this one, then I'll come to T, there is no more choice. S also there is no more choice, 2 only were there, that is also full. So I did not get the answer when the list is empty. That's the same thing we'll be doing here. If the start state is the goal state, suppose S was only the start state, and I will return what? Success, because I have reached the goal state which was start state itself. Otherwise, do the following until success or failure is signaled. Okay, when will failure be signaled? When the list is empty. When the success will be signaled? When I reach the node which is actually the goal node. Generate a successor E. Successor means just the child node. Okay, if I am present here, this is the successor. To the starting state, if there are no more successors, then signal failure. If here no more successors are there, then failure will be returned from this node. But it does not mean that the whole tree is failure. Only this node has failure because it has no more. That's why. Okay, then call the depth first search with E as the starting node. Okay, so if it has another child here, then this will become the starting node, and it will be calling depth first search on this. Again, it will see if it has a child node, this will become the starting node, it will call the child first. Like that, we'll keep on going into the depth until we reach the end. If the success is written, signal success, otherwise continue in the loop. So like this only will be going, and this will return failure, failure. If it has another child, we'll be exploring that, again coming back. If we get success, it's success. If it does not, it does not, right? That's all. So that's what about the depth first search. You have tried the definition of it, and you have tried the algorithm. If you can make the tree also and explain, it will be helpful for you to fetch more marks. That's all what is there in the breadth first search and depth first search. Very important questions from exam point of view. Next we have what are the characteristics of heuristic search. Now we will be seeing in depth what is the characteristics of heuristic search. If they just ask you about the heuristic search, you still have to write the characteristics as well if the marks is more. Okay, like for example 8 marks, if they ask, you have to write the definitions, uninformed, informed, as well as characteristics. Okay, heuristics are knowledge about the domain. The first very important concept in heuristics is knowledge about the domain. How can you give hint if you don't know what the domain is about? It's impossible to give hint without having the knowledge itself, right? Knowledge is the first key thing you need to know when you are dealing with heuristic is what? Knowledge about domain. Next we have heuristic search incorporates domain knowledge to improve the efficiency over blind search. Blind search is the BFS and DFS. It does not know, it does not have any hint, it explores all the things in present in the tree. But if you actually know there is an answer is present only in the left part, you will just search the left part, you'll never move to the right part, right? That's the thing. If you have information, you'll be just searching which is relevant ones. So heuristic search has that information which is knowledge about the domain, due to which it will search only the relevant ones and it will eliminate the unrelevant ones. Okay, so blind search is BFS and DFS, and heuristic search is like non-blind search. Okay, means informed search. Heuristic function, when applied to the state, returns the value estimated as the merit of the state with respect to the goal. When we apply the heuristic function, we'll get to know how much close we are to the goal. That is the merit of the state. What is the state and how much close it is to the goal? The more closer it is to the goal, the more merit of the state. Okay, that's what it is there in the third point. Heuristic might underestimate or overestimate the merit of the state with respect to the goal. Okay, heuristic evaluation function estimate the likelihood of given state leading to the goal state. Again the same thing, these 3 points are same. Heuristic function estimates from the cost from the current state to the goal, presuming that the function is efficient. Obviously it estimates the cost. If you reach from this point to your goal, how much could be your cost based on the probable formulas, and if you reach from another node to the goal, what could be the cost? Again due to some probable formulas, you'll be calculating the probability. So by using those two, you'll be making a decision. I have some formula by which I calculated. If I go through here, it will cost me 1000, and if I go through here, it will cost me 2000. So it will, I'll choose obviously 1000. Okay, so that's what the heuristic techniques are about. And yeah, that was about the characteristics. Moving on, we have the next question, which is the traveling salesman problem using heuristics. Super important question. Don't miss this question at any cost. Okay, what is the traveling salesman problem? First, do you know what is the traveling salesman problem? If you have forgotten, let me revise you. Traveling salesman problem has like different cities are there. Okay, because he is a traveling salesman, obviously he has to go to different cities, and for going to different cities, we have different costs associated with each path. Okay, so suppose that there are 4 cities A, B, C and D. Okay, so A to B it cost me 4, D to C to B to D it will cost me 3, and A to D it will cost me 5, and so on. Now the traveling salesman has to reach all the cities with the least cost. He has to reach all the cities with what? The least cost. So how he should be traveling? So that he travels all the cities with the least cost. One of the thing I can say is like 4. If we reach from 4, then 3, then 2. Okay, so he was in A, then B, then D, then C. How much was the cost? 7, 8, 9. 9 was the cost, right? So he could do that one, and he should travel each city only once. Okay, he cannot travel more than once, he can travel only once. Okay, so that was another thing. Also he has to reach the final city after reaching all the cities. Okay, he has to reach back to his final city. Okay, because his office is here, he has to sell his goods to different cities. He goes to this city, this city, this city, and he sold all the cities. Obviously he has to come back to the office, right? Will he stay there itself? If he gets better job, he'll stay there itself, right? So that's what the thing, he should return back to the city, okay, where he visited, and all the cities should be visited only once. And we should find the shortest route, or which is the most least cost route. Okay, means which route I follow, it will cost me least money. That is the path I should choose. Okay, so if we solve it using brute force, if there are n cities, how many possible paths will be there? N factorial paths will be there. So that many paths to calculate, and which is the most best one, it is exponentially large, so we cannot go with that one. And this problem is called as combinatorial explosion. So these are the points you have to write when they ask you about traveling salesman problem. Just not directly jump into a heuristic method. You have to first explain what is the brute force method. Before that, you have to explain what is the problem. Then explain the brute force method and explain why it is not the suggested algorithm, because it takes combinatorial explosion time to calculate the all the paths and all. So we need a better informed or the hint algorithm, using which we can be only going to the relevant parts. Okay, relevant part means only we'll be choosing those paths which we know that most probably I'll get the solution through these paths only. So I'll not end up exploring all the unwanted paths which will not lead me to the solution also, right? That's what the heuristic method is. In heuristic method, we'll be using branch and bound technique. Branch and bound technique can reduce the complexity time by little bit, but still it's exponential only. As of now, there are no methods found which is not exponential and solve the traveling salesman's problem. Okay, so we need to go with the branch and bound itself. So what does it do is, first it generates all the complete paths and find the distance from the first complete path. If the next path is shorter, then save it and proceed. If it becomes longer, we will not proceed any further. For example, if you have one city here and another city and another city and three cities are there, 5 6 7. Okay, first you calculated 5 here, then you calculated you are getting 6 here. It is less, it is more. You will not proceed further with this one. Obviously whatever is here, it will be more than this one. You'll see this one 7, and whatever is there, it will be more than 5. Obviously it cannot become less than 5 because negative cost is not present. So you will not consider these two paths in the first place itself. Then you will continue with this path and again apply the same procedure, and like that you will keep on doing. But it's not actually that you will be eliminating totally, because it can also happen, like for example the same paths were here. Okay, I'll give you an example. You cannot rely on this totally by just eliminating in the first go. Why? Because if it was 5 6 7 and you thought that 5 is the shorter path, I'll not explore 6 and 7 itself. Okay, I'll not explore only. But here the cost were just 1 and 2, and here it was 50. Okay, now what you will do, if you had followed this path, it would have been the shortest path, isn't it? But what you did, firstly only you judged that it is the longest path, so you eliminated it. You never searched this one. You ended up paying 55 to the driver when you're traveling from this point to this point. That should not happen. So we'll not be eliminating it in the first go. We'll be reaching to the final goal and calculating what is the final path. Then again we will be calculating if it crosses this one, then we'll be eliminating. What I mean is, if it was 60 here, then in this case I know by reaching the goal 55 only costed me, but here without reaching the goal only it's costing me 66, so I should not search further. In that case I'll be eliminating. First I will reach the path, then I will be seeing is the next cost less than that reached path. Reached path is 55. Is the next one less than 55 or not? I should not judge before only, like 5 6 and I have not reached the goal also. 5 6, no, it is shorter. No, I should not do that. First reach the goal, tell me how much is the cost, then you are supposed to eliminate any of those. Okay, so that's what about the traveling salesman problem. How do you solve using heuristics? In heuristics, which method we use? Branch and bound. Repeat after me. Which method? Branch and bound. Okay, keep in mind. Then next we have the generate and test algorithm. Very simple algorithm. If they ask you the this question, it's super simple question. Generate and test, by the name itself you can understand. Generate all the solutions and test the solutions. If the test fails, eliminate it. If the test passes, keep on doing it. That's all. What is the generate and test? If they ask you the diagram, make the three boxes here: generate, process, test. If it is correct or not, then again repeat. That's all the diagram also you have to make. You can see the official notes in that. You can see the diagram as well. So it could be made more systematic by considering only those paths which actually generate a solution. Now using heuristics, you can only keep those paths. By using the domain knowledge, you will get to know what is the most probable paths, and you will eliminate the unprobable paths and just focus on probable paths. Okay, that was about the generate and test algorithm. Moving on, we have the next, hill climbing problem. Super important question. Make sure you know this very well. Okay, what is hill climbing problem? By the name itself you can understand you are climbing a hill. Okay, so first I'll go to the diagram and then I'll be explaining what is the main concept behind this one. See, suppose that there is a hill here. Okay, You went to the hill like this, and hill is becoming big, and it is flat surface here, so you'll be stopping here. Again you'll be going big, means up you'll be going, it is global maximum here. You initially you don't know which is global maximum and which is local maximum. Global maximum means in the whole graph, if you consider the highest point in the whole graph, what highest point is called as global maximum. But you will not be knowing which is the global maximum unless you explore the whole graph. You agree with me? Will not know the global maximum unless you explore the whole graph. Why? Because if you are presented here, you might think like I am at the highest point, here also it is going down, here also it is down, I am at the highest points. What if this one was like this? This would have been global maximum. This is only local maximum at max, you can say. It could be global maximum, it could not be global maximum. That depends on the remaining graph. So that's what the global maximum and local maximum is. And flat local maximum means it's just like the top point here, and here also it is down, here also it is down, but here all the same places are there. That is the flat local maximum. Okay. So how we'll be solving this problem means, how do we get to know actually which is global maximum and which is local maximum without actually exploring the whole graph? Because exploring the whole graph is obviously the brute force, and there you'll definitely get which is the global maximum, right? But we need to apply some heuristic methods, which is the most probable and the shortest method, so that I can get global maximum without being exploring the whole graph. Okay, one hint I can give you, like for example, if there is a function, okay, in that function if you reach some point, okay, if you reach some point and if you go down, okay, you cannot go more than 10 meters down. Okay, so suppose that there is a mountain in some place, in that every peak wherever it is there, and if you go down from the peak, you can just go down 10 meters. More than 10 meters you cannot go down. Okay, so if you get this hint, like this hill is having this characteristic, then what you can do is, once you reach a maximum point, what you can do is subtract 10 from it and see where you are currently lying, and then you will be seeing, I cannot you will be knowing for sure that below this point I will not be going. Is there any other local maximum which is below this point? That's all what you have to search. Because sorry, any other local maximum which is above this point, because below this point you cannot go, there is no other local maximum, so you'll be saving this much search space. Like that, some hints will be there by using which you can get to know probably it will not be lying more low than this, so obviously this is the global maximum. You cannot tell with certainty that 100% this is the global maximum, but with most probability you can tell it is the global maximum itself. Okay, so hill climbing is a heuristic search for the mathematical optimization of the problems. What it does, optimizes the problems. Optimize means it will make the problems answer more optimal, means more better. Optimal means more better and best. Okay, so in the field of artificial intelligence, so a large input will be given, we have to find the good solution to the problem. Okay, so how many types are there? Three types are there. Repeat with me: simple hill climbing, steepest ascent hill climbing, and stochastic hill climbing. Three are there: simple, steepest, and stochastic. So let's see what is the differences. A simple hill climbing means if we reach global means local maximum, it will just choose the neighboring nodes where it has to explore next, and it will go. Okay, that is the simple hill climbing. So it selects the first neighboring node which optimizes the current cost as the next node. So it will choose those elements which will lead more further to the goal. If this is the goal, by using some function I can calculate that if I go to this path, there will be most probability that I will reach the goal. Okay, there will be some functions for that. Okay, so by using that I will be choosing this one rather than this one. If I go to this one, I have come from here only, again I will reach the starting point. I should not do that. So by that knowledge I can get to know I have to go to the right side. Okay, that is the simple hill climbing. Steepest hill climbing means it first examines all the neighboring nodes, then selects the nodes which is closest to the solution state as the node. Here it just select the first neighboring node, but here it examines all the nodes. This is the junior, this is the senior. It does less task, it does more task here. Stochastic means it does not examine the neighbor itself, it just takes a random jump. It takes a random jump and it decides whether to move to that neighbor or examine another. What is the advantage and disadvantage is that if you make a random jump, you might miss the global maximums in between. For example, if a graph is like this, you are standing here. Okay, and you make a random jump you will make, and you will reach here, and you'll see, yeah, it is more, I can explore, start exploring from here. But what you did is you missed the global maximum here in the illusion of local maximum. This is the local maximum, but this is the global maximum. By making random jump, you missed this one here for this one. But what is the advantage is that if you had like this global maximum, and this was small here, you could have and you reached directly here, what you did is you directly reached the global maximum with very short amount of time. That is the advantage and disadvantage of stochastic hill climbing. So it depends on the situation which method we will be following. Okay, so algorithm is also very simple. All the algorithms are simple. First, start from the initial state, apply the operators or through the process, find the new states, explore, move on to the best states, choose which is the best states, analyze, and when the operators end or you reach the best state, then you will be ending. If you don't reach the best state and the operators are over, there is no global maximum. It's a mountain like this. Okay, like there is no global maximum. Okay, so that's what about the hill climbing, and there are the few different problems associated with that, means disadvantages. So a local maximum could be confused with the global maximum. Like suppose we went to a local maximum, it looks like we have reached the global maximum and we can end the problem there itself, right? So that should not happen. To overcome that, we can use backtracking. What it will do, it will explore all the paths. Even if it reaches the local maximum, it will store that this is the maximum as of now, let's move on to the next path and search if I get more value than this one. That is backtracking. Next is plateau. Plateau means all the neighbors have the same value. To overcome plateau, make a big random jump. In this hill climbing, the main concept is we are seeing for the slope, right? Where the slope is going, we'll be going to that direction. But what if it's a plateau? In plateau, there will be no slope itself. Where the programmer should go, he will be not knowing where the program should go. Here also it is same slope. Here also it is same slope. Do one thing, make a random jump. Even if you go down, it's okay, but you will be reaching some. There is a probability that you will be reaching some other position. Even if you reach the same position again, for example, this is a very big plateau here. Again, if you jumped, you reach here only. Make another jump here like that. Keep on doing until the other plateau comes. If it does not come, just exit the program. It's a plateau. Okay. Next is ridge. Ridge means I see ridge. I'll explain you by, suppose that you are climbing a mountain like this. Okay, and this is a 3D mountain. Okay, so here also some people are climbing like this, and here also some people are climbing like this. Okay, and all are going to the final path, but what you got stuck into is you started walking like this, then you moved like this. Here also the slope is increasing, so what you will do, you will move on again, do spiral, again do spiral, again do spiral. That is the ridge. It will take a lot of time. The slope is still increasing here, but if you go like this, it will increase more faster. That is the ridge. So for that, to overcome ridge, what you will do, use two or more rules before testing. Means you should not just depend on one rule that the slope is there. You should depend on two more rules. Explore the neighboring slopes which is more taking more faster, then change your slope. Again, see which is more faster, then change your slope. If you reach a point where the neighboring slopes are lesser than this one, then just follow this one, because this is the most faster. This is less, this is less, most faster, just follow this one. That is known as two or more rules before testing. So by using this, you can overcome the disadvantages of hill climbing. Moving on, we have the next super important question. Explain best first search. Breadth first search and best first search are different. Just the algorithm is same, but best first search will have some hints. Means knowledge of the domain, and it is known as informed search. Breadth first search is nothing but a blind search. It does not know what is the knowledge of the domain. It will search all the nodes. Best first search will only search those nodes which are most probable. Like I told you, if there are two parts of the tree here, left and right part, if I give you the knowledge that there is answer only in the left part, will you search the right part? Obviously no. But breadth first search will not take any hints from the computer. So what it will do is it will search all the nodes. Best first search will take the hint and it will just search the relevant ones. Okay, that is known as heuristic technique. And for implementing that, we'll be using priority queue. Okay, you will be understanding more what is best first search when we consider a star searching. Okay, so that was about the best first search. And for the priority queue means it's just a queue which will store the elements in the order of priority. Okay, priority means most important ones will be stored in the starting part. Okay, so that's what the priority queue is. In breadth first search, we'll be just using normal queue. So by using priority queue, we are implementing domain knowledge, and that is the heuristic technique. So algorithm is same. Create an empty queue, priority queue which is PQ, insert the start in it, and until it is empty, do the delete min, which is the minimum priority, take that, and then if it is the goal, exit. If it is not the goal, explore all the nodes, neighboring nodes of it, and mark them as visited, and which is unvisited, keep marking again. When you reach the goal, just exit it. So for example, see here I'll be explaining you what do I mean by priority queue. In queue, first you will be having nothing, you'll be entering the starting node, then you will be having three choices, A, B, C. Which one you will be entering first? Tell me. These are the cost associated with that. Which you'll be entering first? Obviously this is the least cost, you'll be entering this first, A, then you'll be entering C, then you'll be entering B, right? Obviously you'll be doing that because you need the shorter path first. So in this queue, A is inserted first, so A will also get searched with 9 and 8. 3 plus 9 and 3 plus 8, that will be compared with 6 plus 12 and 6 plus 14, that will be compared with 5 plus 7. Obviously 5 plus 7 is the shortest, then B and C, B, C will be coming here in the first part, then which is the next smaller, that will be coming in the next part, the last one will be coming here. Okay, like that we'll be proceeding and finding out in each level. This is level 1, level 2, level 3, level 4. Answer is here. So when we reach the final goal in the starting part, means first when we reach the goal, that is the best first path we got. Okay, that's how the priority queue and the best first search works. Okay, so if they ask you in the exam, you have to give this definition, what it means, and you have tried the algorithm and explain it using an example. Okay, next we have A star search algorithm. A star search is, we maintain a priority queue here also, but it stores the order of traversal, a slightly different than the best first search. Okay, A star is slightly different than best first search. How it happens is, if you understand this algorithm, I need not, I means if you understand this example, I'll be explaining you how this works. If you understand this one, you need not listen to the explanation of the algorithm as well, you can write by your own. Okay, so what's happening here? Firstly, let me explain you what are the nodes and the edges. This is edges and this is the node. Okay, circle things are node and the straight things are edges. And you can observe that in each of this node there is a number written on top of it. Like here it is 13, here it is 6, sorry 10, here it is 9, here it is 2, 1, 4, 0. Those are the heuristic values. Okay, heuristic values means the answers, when we compute it, this will also be added with the final answer. Okay, this is also the final answer, it should be added with. Okay, that's what the heuristic function is. Now if I am starting again from here, I have three choices, B, C, A. Which one I will choose? B I will choose, because this is the shortest path. So in the queue, how I will store? SB, then SA, then SC. Why BAC? Because it is order BAC, shorter, longer and longer. Which is the most highest cost, I'll store at the last. Least cost will be given the first priority. Like that I will do. Also along with doing that, I should add this also. 6 plus 10, what is 6 plus 10? 16. 5 plus 13 is 18. 10 plus 4 is 14. So when I do this one, I'll get the shorter path as this one. Without adding heuristic function, I'll get the shorter path as this one. Adding the heuristic function, these are the heuristic function values. When I add the heuristic function values, I'll get this as the smallest one, SC. So then in the next iteration, SC will be given the more priority. Okay, after adding the heuristic function, like that we'll keep on doing. Dot 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 means we keep on doing until we compare at each level what is the most cost. For example, if I compare at this level, in which path I will go, I'll get the least answer. So 6 plus 6 plus 4. I should not consider this one when I am considering this node. I should just consider a heuristic value for this one. So 6 plus 6 is 12, 12 plus 4 is 16. 5 plus 6 is 11, and 11 plus 4 is 15. 10 plus 4 is 14. 14 plus 2 is 16. So which is the shortest path? This one, SBE. You got it? SB is the shortest path. Like that again we'll check to the next level, which is the shorter path. We'll eliminate the longer paths, means in the priority queue it will become down down down, and which is the most optimal one, it will come up. Like that we'll do till the goal part, and we'll reach the goal, which is the shortest path in the top priority. That is the shortest path, we'll be choosing that one. Okay, iteratively it will get updated and taken into consideration which the cost is the least. Only the least cost will be taken into the consideration. And here we'll have open and closed list also. What is open and closed list? Open list means the solution is possible from that. Closed list means solution is not possible from that. Okay, and we'll have two things here, g of n plus h of n. F of n is the a star function. What is f of n? F of n is the a star function, and what it has? Two things it has. Which are those two things? G of n and h of n. What is g of n? It is the initial point to the n. Okay, so if there are 5 nodes here and n is here, initial cost to the n, what is the cost? That is known as g of n. And what is h of n? H of n is nothing but n to the goal cost. N to the goal, what is this cost? That is h of n. Add these two, you'll get f of n. At this point, what is my total cost from the starting till the end? Okay, so that's what the A star algorithm works on, the basic principle. And yeah, these are the things you have to write. And the algorithm I did not mention here because you can mention it in your own words. Even if I mention here, it will be very looking very complicated, so you can mention it in yourself. There is no issue. Just get to know how do you write algorithm, like the step 1 what you have to write, step 2 what you have to write. Just go through it once. Okay, in the official notes of the module 1 of 18 CS71, there you can find the pseudo code for it, so you can go through that and learn from there. Okay, next we have AO star search. It is basically the AO star means a and or. Okay, AO means and or star graph. Okay, here also the same thing, very very simple. I'll first explain you the implementation. Once you get to know the implementation, the rest of the things will be very simple. See here, this is the graph given to us. There are totally 8 nodes here, so 6 nodes here and 7 and 8, and in each node we have been associated with a word which is solvable or unsolvable. Here 6 are solvable, these are all solvable, and these are 12 unsolvable. So obviously where I have unsolvable, if I go to that, there is no point in going, right? Because it is unsolvable, I need not I'll not get any solution, that is for sure. So I should just eliminate those points. That's all what we do in the graph. Final graph is this one. That's all, two-step process only. But to tell to the computer, you have to write a lot of process. So for that, we'll be using two lists. Open list will have all solvable nodes, closed list will have all unsolvable nodes. Initially we'll have the starting node in the open and compute the most promising solution, which is TO. Promising solution means just solvable. Which is solvable, you will choose that. Select a node that is both on open and a member of TO. Means if it is open, we'll consider just that. We'll consider those things which are solvable. Remove it from open and place it in close. Why we are placing it in close? If we have a node here, like for example, if you are choosing B, from A, B is solvable, then we choose G, which is unsolvable. So G, whenever we get as unsolvable, that should be placed in closed list. Okay, that's why we are placing it in close. If N is the terminal node, then label it as N is solved and the ancestor of N is solved. If the starting node is matched, then solved as success and exit. If you get the starting node as the goal node, give success. If you get the terminal node as the success, then output that as the success. If you don't get, you have any other ancestors or any other child nodes, then place them all in a new list. Okay, like that we'll keep on doing, and we'll be expanding all those nodes. Once we store in a list, like nodes are there, from this it has two childs. For example, this is A, B and C. From A I got B and C. After I've stored this one, for the node A, what I will do, I'll expand all its successors. Expand n, find all the successors, find their h of n, where and push them into open. If they are open, push them into open. Initially they will be open only, we will not know if it is solvable or not. If it is solvable, we will push them into solvable, and if it is not solvable, means we reach any end point without reaching the goal, that is unsolvable, we'll push them into the closed list from the open list. Then return to step 2 means repeat it until you get the goal or the failure. Okay, that's about the algorithm. Next we have constraints, satisfaction and cryptarithmetic problems. So cryptarithmetic means what? Suppose that we have to send a message to someone, but that message should be encrypted so that no one else reads that message. So what we'll be using is cryptarithmetic techniques we'll be using. In cryptarithmetic techniques, we'll be using the same letters itself. Like for example, the question is send plus more is equal to money. Okay, this is the actual question. I'll be just giving you a hint because I don't think so they'll be asking in exam. Like to implement this whole algorithm, it was not asked in the previous papers as well as in the model question paper. So I just guess that if they ask also, they'll ask that explanation of it, not the actual problem. It is a very less chance, so I did not include the problem also. In fact, it's actually complicated also. So see here, if you have given with these words, you have to assign each of this letter a number from 0 to 9 and it should be unique. No two letters can have the same number, and no number can be given to the two different letters. Okay, so what we'll be doing is to give you a hint of it, I'll be writing it more clearly. SENDMO R-E, because if you get the hint, you can easily solve the problems, right? Money. Now when you assign each of these numbers and when you add it up, it should be same. Like for example, if I assign 5 and 6, 5 plus 6 is 11 and carry is 1 and 1. If I assign D, E and Y as 5, 6, 1, wherever I find E, further I should use the same number. I should use 6 only. I should add, and whatever answer I get, and this answer should be getting here also when we add S and M. So like that, all the things should be satisfied. So to start, I can give you a hint. How do you start? Always start from the left. Where you should start from? Always start from the left. In the left, what we have? This one. Okay. What value could be M? Guess. Any guess what the value could be? M. See, M is here. Whatever you add, it will be present here. But since M is also there, obviously it means that whatever the number is in S and M, if I add it up, there will be a carry, right? And what could be the maximum carry? Since I have to use different letters are there, different letters are present, so different numbers should be added. Maximum numbers are 9 and 8. If I add 9 and 8, it will be 17. So 1 will be the number which I am getting here, carry. So obviously M will be 1, right? So I got the value of M as 1. I'll mark the value of M also as 1. Then I have S here. S plus 1 is equal to O. Okay, S plus 1 is equal to O. Also I'm getting a carry here. Okay, which is the number? If I add with 1, I'll get carry. Which is the number? Which is the number in S such that if I add with 1, I'll get a carry and I'll get O here. I have 1 here. What is the maximum number I can take? 9. If I add 9 plus 1, I'll get 10. I'll get a carry. What if I don't take 9? I take 8. If I take S as 8 and here it is 1, 8 plus 1, 9. I'll just get 9. There will be no carry. If there is no carry, this will be invalid and I cannot assign any value to M. That is the wrong answer. So obviously I know that I should not take 8. The maximum number is 9 here. If I take 9, it is satisfying both the conditions. 9 plus 1. So I got the S value as 9 and M value as 1. So 9 plus 1, 10. O value I got as 0. Like that, we'll keep on proceeding and until we find all the constraints satisfied and we reach to the final solution. That's what is the constraint satisfaction or cryptarithmetic problem. Okay, many problems in AI can be considered as problem of constraint satisfaction. There will be some constraints which I told you, like no two letters can be same numbers and all, and constraint satisfaction problem can be solved using the array any search of search strategies. Okay, many strategies are there, and select an unexpanded node. This is the algorithm part here, and select an unexpanded node of the search graph. Search graph, what it will have, we store the letters which we don't know. Like for example, S, M and O we got to know, but R we don't know. We'll keep R in that, and N also we did not know. We'll store N in that, and so on. What are the letters we store here? That is the search graph. And unexpanded means we have not considered those letters. Select any of those letters, apply the constraint inference rules, apply the rules here to select to the selected node to generate all possible new constraints. So apply the rules here to generate what are the possible constraints and what are the possible answers. Once you got that one, then if the set of constraints contains a contradiction, just eliminate it. Else what you do is you will be choosing the next one. Like that you will keep on doing until you get the complete solution. Okay, then you will return success. Like that you have to do for all those values, and then you have to return success. If you are stuck with any of those values, you did not get any valid value, then the solution does not exist. That's all. Okay, that's what about the cryptarithmetic or constraint satisfaction problem. Next we have explain means and analysis. Means and analysis is nothing but by an example I will be explaining you. See here, in this example you have the initial state as this one and the goal state as this one. Here what's happening? See, this is the initial graph given. You have to make the graph like this. So first what you will do, this is present here, this is not present here, you'll delete that one. Okay, once you delete that one, it graph will look like this. Then you'll be seeing the size. Okay, this circle is here and this circle is also in this graph. Okay, but this one is not present here, it should be present here. So you'll just move it here. Okay, you'll just move the diamond to this part, and then you'll see the size is not matching. So you'll be shrinking this one and you'll be expanding this one, so it will be looking like goal state. Here what you are doing, at each point you are making some changes both in the forward direction and backward direction. This is the key point here. We will be making changes both in the forward direction as well as in the backward direction. That is known as means analysis. In artificial intelligence, we have many such strategies which will traverse either in the forward or in the backward direction, but a mixture of these two is usually appropriate to solve a complex and large problem. Here mixture of algorithm helps us to decompose the problem into smaller problems and then solve each of those problems, then go to the major part of the problem. This is called as means and analysis. Okay, so means and analysis are centered on finding the difference between the current state and the goal state. What is the difference where you are and what is the goal state, where you have to reach? What is the difference between these two? Apply the operators to reduce this difference. So that is what we are doing here also. This is the initial state, this is the goal state. What is the differences? Eliminate those differences, reach closer to the goal state, closer until you reach the goal state. That's what it is there. The algorithm is simple. Find the difference between initial and goal state, find the set of operators, apply to the current state, reduce the difference and apply the selected operator. Okay, sometimes it could be divided into sub problems, that is called as operator subgoaling. So that's all for this video. Hit the like button, subscribe to my channel for more videos like this. Thank you so much for watching. I will see you in the next one.